Solving quadratic equations by factoring. This is going to be part A of a two-part video. Our goals are to solve quadratic equations by using square root property, solve quadratic equations by factoring, and then sketch a graph of that quadratic using zeros, and then write equations of quadratic functions given their graphs or roots. Again, roots means solutions or x-intercepts, and there are no vocabulary for this one. Okay, key concept here is what is a square root property. To solve a quadratic equation in the form of x squared equals n, so the x squared is isolated by itself and there are no other x's in the problem, take the square root of each side. For any number n that's greater than or equal to 0, if x squared is equal to n, then x is equal to plus or minus square root of n. That's what this means right here, plus or minus. So that means if I have something like this, x squared equals 49, you would solve this by taking the square root of both sides, and x then would give you plus or minus the square root of 49, which of course is going to be plus or minus 7. So two possible solutions. Okay, for example 1, to solve for y, we have an actual binomial raised to the second power. So that's the same thing as having x to the second equals 21, but x just ends up equaling y plus 5. So we're still going to undo this by taking the square root of both sides. Square root this one and square root that one. Now the right hand side is going to be plus or minus the square root of 21. The left hand side, the square root will reduce or cancel or undo the power of 2, leaving you with y plus 5. Now you're going to subtract 5 from both sides, but when we subtract this, we put the negative 5 up in the front, the way I've written it here. So y is equal to negative 5 plus or minus the square root of 21. So that really means that y is equal to negative 5 plus the square root of 21, and y is also equal to negative 5 minus the square root of 21. Now you can leave your answers like this, and this would be what we call exact solution because the square root of 21 is irrational. But you could use a calculator and estimate it. So the square root of 21 is approximately 4.58. So y minus a negative 5 minus 4.58. Now our equal signs here, we should probably change them to this little squiggly line. That means approximately equal to. So this one would be y is approximately equal to negative 0.42 and y is approximately equal to negative 9.58, and there are two solutions. Example 2, during an egg drop competition at Anika's school, students must create a container for an egg that prevents the egg from breaking when dropped from a height of 30 feet. That's going to be important. The formula h is equal to negative 16t squared plus h sub 0 can be used to approximate the number of seconds in t, so that's time, it takes for the container to reach a height of h from an initial height of h sub 0. So h sub 0 is my initial height. So find the time it takes for the container to reach the ground. So when it reaches the ground, h is going to equal 0. So in place of this h, we're going to put 0. Negative 16t squared. Now h sub 0 is the initial height that they said. Well, the initial height was 30, so this is going to end up being plus 30. And now to solve this, we're going to isolate the second power. So we have to get rid of the 30 first. So we're going to subtract 30 from both sides. So negative 30 is going to equal negative 16t squared. Then I'm going to divide both sides by negative 16, and that will end up giving me 1.875 equals t to the second power. And then to solve for t, we're taking the square root of both sides. So take the square root of both sides. We end up with t approximately equal to, and I'm going to use a calculator for this one, plus or minus 1.37 seconds. Now remember, we're talking about the context of a problem, so this negative 1.37 seconds doesn't make sense, so we're not going to include that. So the solution would actually be the positive 1.37 seconds. Okay, so now we're going to solve by factoring. Now remember, another name for solving or solutions of a quadratic are called roots or zeros or x-intercepts. So from the graph, we can actually see that the solutions are negative 1 right here and positive 4. So we know that those are the solutions. But watch what happens when we put those numbers into the function. So I put a negative 1 in for here. and then I evaluate f of x, I get negative 1 squared, which is 1. 3 times negative 1 is positive 3 minus 4, and I end up with 4 minus 4, which equals 0. So f of negative 1 ends up outputting a 0. So I end up with negative 1 comma 0. That's expected because that's what happens at the x-intercept. Then if I put a 4 in there, and then I evaluate, 4 squared is 16, and negative 3 times 4 is going to give me negative 12, and then minus 4, so I end up with positive 4 minus 4, which equals 0, so f of 4 also produces a 0, or 4 comma 0. So what that means to our quadratic is we want the output to be equal to 0. As you can see, it's 0 in both cases. And then when we solve for the value of x, we get the solutions, or the x-intercepts, or zeros of the function. So we're going to substitute this f of x with 0, and then we're going to factor this quadratic. So we're going to write our two binomials, and the factors that make x squared are x and x. And then we want to find the factors of negative 4 that have a difference of negative 3. And it would appear to be a negative 4 and a positive 1. So I will put minus 4 and plus 1. So how do we get the solutions of negative 1 and 4 from this point of the problem? Well, if I have two numbers here multiplied together, x minus 4 and x plus 1, and their product is equal to 0, then that means one or both of those two factors have to equal 0. So I'm going to take x minus 4 and set it equal to 0, and then solve that, and I get x equals 4, and there's one of my solutions. And then I'll take the other binomial that came out of that factorization, x plus 1, let it equal 0, and I end up with x equaling negative 1, and there's the other solution. Example 3, we want to solve this one. We want to use the distributive property when c is equal to 0. Notice there's no c value over here, therefore c is equal to 0. But in any case, you still have to start with the function equaling to 0. So we're going to look at these two numbers. So we ask ourselves, what's the GCF of those two numbers? And it ends up being 4x. When we factor a 4x out, we're left with an x minus 3, still equal to 0. So we're going to use the zero product rule again. So this is a and this is b. So we're going to let a, which is 4x, equals 0. And we're going to let b, which is x minus 3, equals 0. And we're going to solve both sides. So x is going to equal 0 over here when I divide both sides by 4. And on this right-hand side, when I add 3 to both sides, x ends up equaling 3. So the solutions are 0 and 3. Okay, so they're asking us to solve again, but also go a step further and sketch. But we also have a trinomial. So I'm going to write my binomial setup here. Two binomials multiplied together will give me 0. Factors of x squared are x and x. Then I want to find the factors of negative 8, which is our c term. So the factors of negative 8 that have a difference of negative 2. So it looks like it's going to be negative 4 and positive 2. So I put minus 4 and plus 2. Again, this is a and this is b. So if a times b equals 0, then a must equal to 0, or b must equal to 0, or both. And I just keep solving. So to solve this side over here, I'll just add 4 to both sides, and x equals 4. And to solve this next one here, I'm going to subtract 2 from both sides, and I have x equals negative 2. So I know the solutions are at 4, 0, and negative 2, 0. So I'm going to put dots on the graph in those places. So we've got 0 here and a 0 over here. If we look back at the original function, now remember this right here is the y-intercept, so I know it's going to cross the graph at negative 8, but I also want to know where the vertex is. Now there's two ways you can do this. You can find the axis of symmetry, which is going to be x is equal to negative b over 2a, and then substitute it in for x and calculate the y value of the vertex. But the axis of symmetry is going to be the one value that's equidistant from these 2 points. So what is the distance between the 4 and the negative 2? Well, the distance there is 6. So if I take that distance of 6 and then divide by 2, we know that the axis of symmetry has to be 3 units away from both of them. So if I go ahead and count 3 units away from the right-hand side, I end up here at 1. If I count 3 units away from the left-hand side, I end up at 1 again. So I know that the axis of symmetry has to be x equals 1. So to find my vertex, I'm going to substitute 1 into the function and figure out what the output is. So I'm going to put a 1 in place of x and calculate the output. So 1 squared is 1. Negative 2 times 1 is negative 2, and then minus 8 has the equal f of 1. So 1 minus 2 is negative 1 minus 8, and that's going to give me negative 9. So my vertex is going to be at 1, negative 9. And 1, negative 9 is right here. Now remember, my axis of symmetry is at x equals 1, which is right here. So I can reflect this point over here, and it will be on this side of the graph. And then I could just draw my best curve through my graph. And that's our sketch. Alright, so for example 5, they want us to solve by difference of squares and by the square root property. Now the first thing you'll notice is this is a perfect square and this is also a perfect square, and there's a subtraction between them, which means they are difference of squares. Remember that difference of squares come from a plus b times a minus b, and they produce a squared minus b squared. And this pattern right here matches the pattern that's over there, which means I can factor back into this format really quick. So I know I'm going to have two binomials, one plus and one minus, and I take the square root of the first one, which is going to be 7, and that goes in the first position. And I take the square root of the second one, which is going to be x, that goes in the second position, and it's still equal to 0. And I just use the zero product rule here, so 7 plus x has the equal 0, or 7 minus x has the equal 0. And then we subtract 7 from both sides over here, we get x is equal to negative 7. So on the second binomial, when we subtract 7, we get negative x equals negative 7, but we got to get rid of this negative sign, so we're going to multiply both sides by negative 1, and we end up with x equaling positive 7. So you can see the two solutions are 7 and negative 7. Now when I have a scenario that looks like this, where there's no other x's in it, I prefer to use the square root property. So as I rewrite that problem, you'll see how much quicker this will end up being. So I'm going to subtract 49 from both sides. I end up with negative 49 on the right. Multiply both sides by negative 1 because I don't want this to be a negative there, so I end up with an x squared equals to positive 49. And then take the square root of both sides and end up with x equaling plus or minus 7.